Hello there. Welcome to the archive. We're doing more jukebox stuff today. I don't know specifically if we will uh, generate stuff today because frankly I think I used all my quota trying to upsample yesterday, but it got killed. I did all of this and nothing of it got saved. So that's what we're gonna try to remedy today by building our own upsample function from the source, which frankly does some saving in between. Or does X amount, so I can do the saving manually in here in the notebook, which I think I'll do actually. So let's get to the jukebox git. Here's all this. This is if you actually run it from the command line and stuff like that. Nothing we're interested in. What we want is sample.py here. We want to read the source. And there's going to be a function here called upsample. Upsample given already generated upper level codes. That's what we call. We call it with z's, our labels, our sampling quarks, our priors, and our hyperparameters. We create sample levels, which is a list of a range of the length of priors, -1. Yeah, makes sense. Because when we're upsampling, we already have the deepest level. And then we call sample. Now, I think sample partial window also calls that same function. Or it doesn't. Upsample calls underscore sample. Underscore sample is called I think they are indenting pretty good, so I think I can put a space there. Underscore sample is called from upsample, primed sample, ancestral sample, continuous sample. Sample single window, which is called by sample partial window, which is what we use. What does underscore sample do? Like I'm trying to figure out the separation between the generation and the upsampling, like how tied together that is. Also, I forgot to check, but like how tied. Yeah, that's working. Speaking of, yes, we do have desktop audio. Hurrah! Basically, we have, so it runs continue sample or ancestral sample. That calls underscore sample. Now, up sample calls underscore sample. But we use some weird sample partial window. It's only used in sample level. Which is used in, no, wait. Yeah, it is used in sample. Okay, okay. So it's all tied together. What? Why isn't that being marked? Oh, now it is. Okay. But yes, but yes. So, does that mean I can call sample partial window with the upsampling network here? Mm, uh, how does upsample work? Upsample, what do you run? You run underscore sample, literally. Um, hmm, hmm, hmm. Oh yeah, yes, it was made into a range. Gets the prior, which in this case is the upsampler, moves it to CUDA, empties the cache, and then samples the level with it. I have an idea. And that is to take the upsampler that we generate here, and we are just gonna hmm, I have no idea. Let's copy that. Actually, what depends on that? Probably a bunch of this, or not. Well, I want these also, probably. I'm gonna copy this up here somewhere. The upsampling and the generation is the same network. It's gonna make the... What? What? What the heckle? How do... how do fix? Because that's gonna be the middle prior. The upsampler is just the middle prior. sampling level. Well, I guess we set that to 2, so we get the equivalent function for now. Sampling level is... yeah, we're just gonna put that in there directly, I guess. So we're gonna load VQVAE and a prior, depending on the level, sampling level we chose. Okay. Something tells me this is gonna go wrong all over the place, all over the place, all over the place. Like, I know this here, that has a purpose, and that comes into play into level 1 and 0. So, oops, but I don't know how we'll solve that later. Yes, I think it's here that I need to change and put in sampling level there. For now, I'll just do this. If sampling level is equal to 2, aka lowest level, it should do that stuff. I'll tell it to save to the sampling level of a checkpoint, I guess. Actually, I'll keep it all in one checkpoint for now. If it's that easy, I'm gonna flip out. It does mean I have to like go back and reload the top prior though. Also, I should probably say that you should sample tokens to sample if sampling level is 2, else 4096. I think. Sure, unknown. So we have equivalent function now. Supposedly. When we change this to 1, However, we are sampling on a level up. I assume that's going to look at the level below it. Who knows, not me. I don't believe I have much quota, if any at all. So I might as well just continue to look at this and be like, what can I improve? And one thing immediately that comes to mind is this. This should... Okay, I'm starting to get their logic. They're looking only below and generating above. Okay, yeah, makes entire sense. For VQVAE, that is. Also, I forgot, but there you go. Zoom. Maybe that's a bit too much. Also, I should probably get rid of this, since that never worked. We might reuse this line if I figure out how to properly... if I can figure out if this check here has any influence on this layer, or if I can check like why the different layers have different alignments or something. I'm not entirely sure what's happening with that yet, but I think it's just a matter of delving into the numbers and see what's actually going on. But I haven't done that, so I can't really tell. Ooh, how about the parameters? Temperature for upsampling is 0.99, supposedly. I think I got this temperature set to 0.995. Yeah, okay, there's gonna be weirdness in either case. But hey, let's try it, I guess. Let's see if we have anything in regards of quota. Nope. We have no quota. I ran out of quota, so I can't test the changes I made. Sad face. Also, this is not needed. And why did I move the access to CPU? That's weird. Either way, that should move the functionality of this upsample function up into my weird little loop here where it does saving in between, and it saves it back to my drive. hopefully this will work. I mean, theoretically it should, since upsample calls sample, which calls sample level, which calls either sample single window or sample partial window, and we call sample partial window. And yeah, we use directly call sample partial windows with some relevant variables, and I mean, it should be okay. I don't see. It's the exact same flow, just with a different prior, and with the level set to a different variable. This here, level, where's that used? It's used in sample partial window, yes, which we also use. Where's level used there? Ah, it's used to just select the correct tensor to do the work on, because we have a list of free tensors representing the free levels, level 0, 1, and 2. Level 2 being the most compressed and noisy, level 0 being the least compressed and least noisy. Interesting how sample partial window actually calls sample single window. It sets sample tokens sampling quark, which is then used in single window, I presume. Sample tokens. If sample tokens in sampling quarks, sample tokens equals sampling quark sample tokens, else it's just ends negative the start, so the entire thing. So yeah. A lot of this just seems to be like helping and wrapping functions for, I think, this function here, sample single window. I mean, this probably also calls other stuff. Actually, no, it just seems to do the things. It splits the batches, it goes through them, samples the prior on them, gets the outputs, and concatenates that to what we already have and returns it. Or something along those lines. I skimmed that very much. Oh, here's that conditioning thing. Like, I wished I could speed up this part or cache that part. Maybe that's close to where this is. Whoops. There. I guess it's in prior that it does the rest of it. Prior sample. Yep, here's a lot of stuff. A lot of calls to stuff. Prime sample, sample, get encoder, prior post process, prime sample, prior pre post process, get condition, or get called. Currently, X condition only uses immediately above layer. Okay, to me that sounds like layer 0 doesn't care about layer 2. It's sampling only from layer 1. So layer 1 needs to transfer all of the information through from layer 2 and upsample. Maybe that could be made more efficient. Here's that get C conditions. Seems like it takes a chunk of Z's. And it gets a specific chunk of it or something. Yeah, it gets a specific chunk. Anyway, that's... I think I've looked through everything I can. Kinda sad that I can't test it. But I guess that's... I guess that's just stuff. Also, I should change this to be sample tokens. Yeah, I have to fix that somehow. I need to check. Oh yeah, I remember that. The initial VQVAE encode brings 8 samples into one token at level 0, and then it's compressed by 4 tokens each level, and there's 3 levels, so at the end you end up with 128 samples per token. Makes sense. Yes. And raw to tokens is 128. But that should depend on the level. To do fix me. Leave it at that. Oh god, we got quota. Probably not a lot, but Jesus, okay, we got quota. Holy crap. Let's link this. Link my drive. Jesus, we're going fast now. We're gonna... Yeah, I think this might work. Although I doubt it. I am gonna change this. Or will I? I may not. I may change that to 2 even. Come on, initialize. Thank you. We're loading. We loaded VQVIE and we have loaded prior level 1, yes. We're gonna load our prime sample, whatever. Make sure that any of these variables are available. We're gonna run top prior, which is actually our middle prior, labeler, get batch labels. Let's see if that exists. Ooh, we're also gonna do raw to tokens on that thing. Whoa. Okay, it still returned 7.7 million, that's what we want. We want to load our access. And we will say bye-bye to all we hold dear and near to our hearts. $32 is raw to tokens now. Okay. Does that line up? Yes. Good. I'm understanding more and more of Jukebox the more I use it. Hopefully. Yes, hopefully this will be pain-free. Also, we got a fast GPU. Wow, Jesus. Yesterday, when I was trying to upsample, I was sitting at 8.7 with this prior, and now we're sitting at 14. We're doubling ish. How much RAM are we eating? 5 gigs. Okay. I'm just I kind of regret setting it at 2 even. I kind of want to just set it at 1. Hmm. Normally, like we already have a very small amount of stuff in the level 1 tensor. Like, yeah, maybe only 30. But it's not supposed to be that many in the beginning. It's supposed to be 8,000 whatever negative what we have, and then it's half, which is 4,096. So this might go to hell, who knows? The boundaries of the generation is not going to be aligned with the song start now, at least, which might be weird. Network might freak out. Interesting how we like just got quota though, as I was well doing this. Also, I should probably show you what I upsampled. Or what we are about to upsample, I should say. We are about to upsample this. That's what we're gonna upsample. It's a fairly generic, I give it 2 beats, it generates 2 beats. It's the exact setup we have here. We give it tokens to sample and tokens to sample for both parts, and tokens to sample is 2 times a beat. And I give it the first 2 beats of any bar and it generates the other 2. That way it actually keeps the chord progression, which is nice. Is this done? It is. Without errors. What did it generate? 11 seconds of upsampled audio. I like it. I think there was some glitch there in the beginning because we didn't align the... We immediately sampled 4096 tokens instead of 7000 whatever that we should have, because we already had 900, or oh yeah, it got removed, but we already had I think it was 960 tokens. We needed to do 8000 something. $8,192 negative 960. We needed to do 7,232 instead of 4,096, and that may have glitched it, but I don't think that should be further of a problem. Now there's going to be a bit of a weird aspect going on here, because when we encode, we get all 3 levels, but I only take the bottom level, or the top prior, and add that. So now when we're generating in the middle level, level 1, we're actually generating what we technically already have tokens for. So it's gonna... Jukebox is gonna have its own take on the compressed tokens something something. I don't even know. It may be weird. We shall see. Still though, that's not too bad of an upsample. Yeah. I mean, hell, given how this is set up now, I might even be able to change this to level 0, sampling level 0, and have this function do all of it. And if I'm smart even, I might be able to remove this if here and do this on all the levels. Or, well, do it on the current level that matters. And like reduce the generation time on every level, because basically half of the tokens will be copied from the VQVAE encoder instead of being generated out of thin air, or out of thin electrons, I guess. So that should save some time, since the the encoding is is really fast. Although it is top prior.encode and not vqvae.encode. So this is like, hmm. 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 Yeah. Like my main thought now is like, if it has an encode, it probably has a decode, which means it's probably like some kind of autoencoder, or it's at least it's probably shaped like that in kind of a way. And that kind of makes me wonder, how is the generation actually achieved, you know? Like, do you just feed noise into the center of the autoencoder, or I don't know idea. I have no idea. I know way too little. Maybe it says in the README in Jukebox here. Prior. Train prior or upsamplers. Once the VQVIE is trained, we can restore it from its safe checkpoint and train priors on the learned codes. To train the top level prior, we can run a command. To train the upsampler, we can run another command. We pass sample length equals number context times downsample of levels, so that after downsampling the tokens match the number context of the priors hyperparameters. Here, number context is 8192, and downsamples equals 32 and 256, giving sample lengths equal 8192 times 32 and 8192 times 256, which is equal to 65,536 and 2,097,152 respectively for the bottom and top level. I thought there would be more information there about the difference or... Reuse pre-trained VQVAE and train top-level prior of new dataset from scratch. Blah blah blah. Is this done soon? This is just stuff about training with lyrics and labels, artists, labels and stuff. And we seem to be done. Let's check our other new 11 seconds. Yes, total of 22 seconds. Okay, nice. Let's see what it got. Okay. I mean, I think it's working. So I'm gonna be a madman and say, yeah, 8, sure, go. This is gonna take a while. This is gonna take 11 seconds plus 450. 4 times 60 plus 50 plus 11. 311 seconds. 5 minutes and 1 second. For one generation. We're gonna do 8, I think it was. That's 40 minutes, isn't it? So 2,400 seconds is 40 minutes, yeah. We're not gonna have an output for another 40 minutes. But the good thing is that our checkpoint yes, it was modified recently. Like it was literally 324 and it's now 328. So it is saving it. Which means, yay, I now don't have to sit through all of this and then get the pain of Google being like, nah. just because the source code of that upsample function doesn't bother to do any checkpointing, at least to to the hyperparameters name path here, which it does do in the end of each layer. When you've upsampled from level 2 to level 1, it does create a checkpoint in your drive if you have it linked to the drive. And you can load in from that checkpoint just fine, just by running the same upsample function again. And it will just like remember, like, oh yeah, all that sample already, and it will just do it and then jump up. But if you don't get all the way through level 2 to 1, then you get aborted like this, and then you can't save your results at all, which that's fun. But yes, I will kind of babysit this for the next hours, or well, I will do other things, but I will rerun this and come back every 35 minutes and so check on it, be there to restart it, and maybe even, yeah, of course I will listen to it, but maybe I will tell it to do level 0 also, but that's risque, because frankly that's too much generation. I think it's like 9 hours of compute time on a V100 or a P100 for a minute or so, 50 seconds maybe, 70 seconds, depending on your sample rate, of course. It's like, it's a bit too much. But yes, I will let this do its thing. And we'll see what I do with the actual thing here. I may post it to the YouTube channel as a video, like Deadmau5 Snow Cone, but beats 3 and 4 are by Jukebox, or something like that. We shall see. In either case, it's running fine again. It's on its second iteration of 8. Hurrah, hurrah. But yes, I've nothing more to say, because this is now just compute, and that's boring. So I will go and do something else, and as I said, I'll check up on this, and I'll probably post the resulting audio as an actual video or something, or maybe I'll just review it in another stream here. We shall see. In either case, goodbye.